Hello everyone and welcome to this video on properties of definite integrals. Okay, um, these are not too bad. I think these are relatively easy. One thing that we have to know before we can really dive into this is the following: that if we integrate a function, that what that's going to give us is, so if I integrate an antiderivative, it's going to give us f with no I can't speak, I'm sorry. If I integrate a derivative, it's going to give me the function with no derivative, oh boy, I forgot one thing. If I integrate from a to b, definite integrals, everybody, losing my brain. Okay, f of b minus f at a. Okay, so this just comes from the definition of integration. So the first thing I want us to notice, okay, is the following: that f at b minus f at a is the negative of f at a minus f at b. Okay, and if you're not sure about this, then just distribute, right? Negative times this will be negative f at a. Negative times negative will be a plus f at b. Okay? Now, here's the thing about this. This is the negative of, and now this is going to be the integral from b to a. Okay? Because again, think about it. Think about what we're doing here. Okay? So we're integrating a derivative. So we're going to have negative, and then we're going to have f at a minus f at b. Okay? And again, if I distribute, I get exactly what's here. Okay? So here's the point. Okay? Here is the point. The point is this. Okay? The integral from a to b, some function, is the negative of the integral from b to a. Okay? So in other words, if I want to swap the limits of integration, I may do so, but it costs me a minus sign. Okay? This is a property that we're going to use again and again and again and again and again. So let's keep this one in mind, right? If I swap the limits of integration, I have to, it's going to be I can do so, but it's going to cost me a minus. Okay? So that is big property number one. And let's see, we got a few more properties here. Let's look at property number two here. Let's just look at some examples here. Let's say I have integral 6 multiplied by f of x minus 10 multiplied by g of x, and then that's integrated with respect to x. So the first thing that we can do here is we can do this piece by piece. Okay, so we can do integral 6 fx dx minus integral 10 g of x dx. So basically you can distribute integrals over addition and subtraction. Okay? And we can also take constant multiples and put them in front of the symbol of integration. So in other words, this is going to be 6 times the integral of f of x dx minus 10 times the integral of g of x dx. Okay? And, a common type of exercise for something like this would be they'll tell you to evaluate this, and what they'll do is they'll tell you that the integral of f from like -1 to 1 is like, I don't know, 14. And then they'll say integral from -1 to 1, g of x is like 23. And then so they'll ask you to find the integral from -1 to 1 of all this. Okay, very typical type of question here. So we would just use these properties that we've already used, and then we would just plug stuff in. So integral -1 to 1 f of x dx, that's going to be 6 times 14 minus 10 times 23, right? So whatever that number is, that's the result. That's how you would do that problem. Awesome. Okay. What else do we have? Let's look at just some graphical things really quick. So if I have something like this, clearly, let's say this is A1 and this is A2. Clearly A2 is bigger. Okay, so let's say this is -3, let's say this is -2, and let's say this is, I don't know, 1 over here. If I integrate from -3 to -2 of my function, then that's literally just going to give me A1. If I integrate from -2 to 1, that is going to give me A2. And then if I integrate from -3 to 1 of my function, that is going to give me A1 minus A2, and that will be negative. Okay, so yeah, so little properties of integration there. And then there's one more really important property that we need to go over. So let's do that right now. Okay. Here it is. So the integral from A to C is the same thing as the integral from A to B plus the integral from B to C. Okay, so what does that look like? Let's say if I have, I don't know, A, C, B, right? So if I have a curve, the idea is if I want the integral from A to C, the whole thing, then I can break that up any way I want. I can pick any value in the middle and break it up. Okay, so I can integrate from A to B, and that will give me basically this and this and this added together. Okay, it stops here. So it'll give me whatever the result of this minus this plus this is. Okay, and then plus integral from B to C. That is going to be this guy. Okay, B to C. Put it in purple there. Will give me this one. Okay, so yeah, so this is the other property of integrals, definite integrals. We can split an integral any number of times, and then just basically do each one individually, and then add or subtract them together at the end. Okay. Awesome. Yeah. So this is a pretty good little summary. Let's see. Can we do an example? we'll do an example in the next one.